Have you ever stopped to think about the circulatory system of a modern city? No, not just the roads and the subways. I'm talking about what's right underneath our feet. There's this huge invisible network of arteries, and they're carrying the absolute lifeblood of our world, electricity. It's a hidden marvel of engineering we all depend on every single second of the day.
So, how in the world do you even start to wrap your head around something that complex? Well, luckily for us, we've got the map. For this explainer, our guide is the Power Cable Handbook. It basically lays out the entire blueprint for how these critical underground systems get designed and built. Okay, let's get into it. So here's our game plan. We're going to start with the big picture, then unpack the 6-step master plan that makes it all happen. We'll get into the design, the actual construction methods, take a look at the anatomy of the cables themselves, and then finally, see how this hidden world connects right back to ours. Right, so let's tackle that first big question. I mean, we're demanding more and more power every day for our phones, our homes, our entire industries. So how does all that energy travel completely unseen through the most crowded parts of our planet without us even knowing it's there? Okay, so how do you even begin a project of this magnitude? It's not like you just go out and start digging. No way. It's an incredibly methodical process, all broken down into a master plan that makes sure absolutely nothing is left to chance. Everything, and I mean everything, follows this 6-step life cycle. You start with a high-level planning, then you get into the nitty-gritty of the design, and then comes the heavy lifting, construction. After that, it gets commissioned, turned on, and then it's managed for decades through operation and maintenance. It is a total cradle-to-grave approach for our most critical infrastructure. Let's dive into those first crucial stages, planning and design. It's really all about one thing: reliability. The whole goal is to build a system that is so tough, so robust, that you never, ever have to think about it. And that takes some seriously clever engineering. So the secret sauce is this principle called N-1 contingency. So N is just the number of components you need to get the job done. N-1 means the system can lose any single one of those components and still work perfectly. It's built-in redundancy. It's the engineering magic that stops one little problem from knocking out power to an entire neighborhood. And now we get to the part everyone thinks about: actually getting these massive cables into the ground. This is where all that careful planning and design has to face the messy, unpredictable reality of what's actually buried under our streets. You basically have two main strategies. First, there's the classic open cut method. You literally dig a long trench. It's direct, sure, but it causes a ton of disruption. The other option is the no-dig method, which uses these incredible guided boring machines to tunnel underground, creating way less chaos up on the surface. And wow, the difference is just striking. That open-cut trench, it's like performing open-heart surgery on a city street. But the guided boring machine, that's more like keyhole surgery, super precise and way less invasive. Which one they choose really just depends on the environment. And it's not just about digging a hole. It's a high-stakes, 3-dimensional puzzle. This table gives you an idea of the minimum space you have to leave between a power line and other utilities. We're talking about staying just 300 millimeters. That's about a foot away from a gas line. Or check this out, over a meter away from a high-pressure steam line. A mistake here is just not an option. All right, now let's talk about the star of the show, the cable itself. And believe me, this isn't just a wire. It is a highly sophisticated piece of technology, engineered to perform perfectly for decades.
Seriously, think of this thing like a piece of high-tech armor. At the very center, you have the copper conductor. That's the hero carrying all the power. It's wrapped in super thick insulation to contain all that energy. Then come the defensive layers. You've got water-blocking tapes that actually swell up to seal any leaks, a copper screen to handle any faults safely, and then another moisture barrier. And the whole thing is wrapped in this tough outer jacket, a rugged shield that protects it from rocks, chemicals, you name it.
Okay, so we have this incredible network, all planned, designed, and buried deep underground. But how does it connect back to the world we can actually see? How does it power our lives? The answer is this pretty unassuming piece of equipment: the riser pole. This is the crucial bridge between the world we see and the world we don't. It's the exact spot where that heavily protected underground cable finally comes up out of the ground and connects to the overhead power lines that feed our neighborhoods, our offices, and our homes. So at the end of the day, all of this immense effort, the planning, the surgical construction, the advanced technology, it all leads to a power grid that's stronger, safer from storms, and way more reliable. And hey, it's also less of an eyesore. It just makes our communities more resilient and better places to live. When you see just how complex and beneficial it is to bury our power grid, it really gets you thinking, doesn't it? As our cities get smarter and more crowded, what's the next piece of critical infrastructure that we should take from the skyline and move into the subsoil? What else is ready to join this incredible hidden world we're building right beneath our feet?